Okay, already. Okay, so today we will continue the last part of your chapter 4, interpolation. So today we will continue with the piecewise polynomial approximations, and in your syllabus, the natural to Spline only covered in your syllabus. Okay, so we go to the intro first. Intro. This cubic. This piecewise polynomial. So so we continue. Okay, let's explain a little bit about this piecewise. Sorry, SE polynomial. Interpolation. Okay, let's consider we want to make a polynomials to go through all data point. Go to all data point. Okay, and if let's say for example, we have hundreds of data. Then 100 data, how many degree of the polynomials? It's a 99-degree polynomials. And so if let's say we use the previous techniques, so the value is become unpredictable and it will become not accurate. Okay, if we want to do the interpolations like a previous Laplace interpolations, kan kita buat macam ni, macam continue. So it can be not accurate because we have like point to point. Contoh let's say we have like saya tak buat sampai 100 lah. For example, like here, let's say we have a graph like this. And let's say we have a line. Let's say I draw a line, maybe something like this lah. And let's say we have a point, 1 point, 2 point, 3 point. Lama apa ni lah. 4, 5, 6. Oh, dia jadi anak panah. Patutlah. Okay, let's say this one. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 data point. We want passing through all the points. Okay, so but then this one sedikit saja. Okay, so it will be more. It will be a better when we change this polynomial to a we call a lower degree lah. Polynomial. Kalau tengok ni saya pun tak tahulah, mungkin graph dia lain lagi sebab dia kat sini. Okay, so to a lower polynomials, in order and then we call it a cubic. We call it cubic spline lah. Okay, so that it can be every pair of data that we will use like this. Okay, now the whole this one. So I will separate it this one based on segment. This segment. Sorry, this one should be like continue lah. Like this. Saya akan ubah dia macam ni. Let's say this one, katakanlah kita tulis this one is, let's say this one is X. X0, X1, X2, X3, X4, X5, X6, X7. Katalah kalau kita tengok we have 8 data points. Yang ni kan 8 data point kan. Kalau 8 data points, that means N is 7. Right. Kalau tengoklah kita punya X tu X7. And then sekarang saya nak pecah kepada segmen-segmen. So, this piecewise polynomial adalah saya akan buat dia macam ni. Saya akan adakan satu dia punya how to say, cubic spline yang di mana dia akan merangkumi macam ni. So, you will have a S0, S1, S2, S3, S4, S5, X6. Nampak? So saya pecahkan based on the interval. So that means here S0 is from let's say this one lah, A and until B. Okay, and let's say this one is C and this one is D. Seterusnya lah. So saya akan pecahkan macam ni lah dia. So dia punya teori behind like this lah. So one more thing is we want to make the cubic spline, okay, so that it can the data point can go through every point. But then go through every point, when it's too much, it's more easier to do the approximation when we separate it into several segments. So yang ni kita gunakan cubic spline ni lah. So a cubic spline, we do the interpolations, okay, and then we call normally now. Selepas ini kita akan guna as x, ya. So sebelum ni for the Lagrange interpolations and Newton divided kan biasa kita guna p kan, px. So now we will use this term lah, s, okay. So for this cubic spline, when we want to do the interpolations, a cubic spline interpolate as this one for the function. Let's say we have one of the function. Yang ni mesti ada satu function ni. This one. Yang ni. This one graph panjang-panjang. This can be mesti ada satu equation lah panjang-panjang ni kan. Okay. So the cubic spline as this as have to satisfy the following criteria. This is the criteria that this cubic polynomial have to be satisfied. So dia totalnya ada 5 and secara amnya ada 6. It's actually got 6, but the 6th one is we want to define whether this piecewise polynomial is a natural or clamp. Okay, but this one, because this one is not covered in your syllabus, so we will only look at this one lah. Okay. So the 6 criteria is like this. Okay, saya zoom besar sikit. So the first one, it said that the Sx is a cubic polynomial denoted by Six on the subinterval xi plus 1 for each I equal to 1, 0, 1 until n minus 1. Macam ni lah contoh gambar rajah macam ni yang tadi saya lukis. So let's say this one. The whole this one, saya jadikan sebagai Sx. Maksudnya saya punya Sx, my Sx akan merangkumi S0 x, this one, S1 x, this one, and sampailah S6 x. Okay. Bukan stuck. Understand or not? Because our n here is 7, right? So look, it have to be until n minus 1. Kalau n is 7, that means until 6 lah. S6. So kalau tengok sini, saya ada 8 data points. N adalah 7. So saya akan ada dia punya sub polynomial tu akan ada sampai 6 lah. Okay. So dia akan pecah ni lah kepada interval. So total yang ni akan ada 6 jugalah. That means here, okay, for example, this one be from x0 until x1. And this one is a x1 until x2. And continue lah, x2 until x3. And the last one will be x6 sampai x6, x7. Sampai last kali x7 ni lah. Sampai this one. Contoh. Okay. So this is the first criteria, first conditions. And then the second one is saying that S xi have to be equal to fxi for each I go to 0, 1, and until n. So the meaning here that we want the spline function passing through all the nodes. So kalau sini, let's say, here, maksudnya, tak kisah contoh saya punya formula ni, apabila saya dapat formula ni, this is the formula that we want to do. We want to construct this new formula. So dalam formula yang kita buat yang baru ni, this spline, cubic spline formula, apabila kita gantikan nilai x, apa-apa nilai x, dia mesti sama dengan function yang nilai itu apabila kita gantikan nilai x tu juga. Boleh faham ke tak? So the blue one, this one, kan dia akan ada functionnya. Okay. So but this one, yang ni cuma ada satu equation saja. But this one we will have 6 equation. Kita pecah kepada 6 tau. Setiap satu ni jadi akan satu. Setiap satu tu jadi akan ada equation dia tersendiri. Okay. So apabila kita ganti apa nilai saja, contoh saya ganti x2 here. So here also x2. Okay. Here also x2. So the answer for these two have to be same. Mesti sama. Okay. So that means kalau macam tu barulah maksudnya this spline function passing through all the data points, all the nodes. Okay. And the third condition is saying that, okay, si plus 1 for xi plus 1 equal to xi plus 1 for each I equal to 0, 1, and until to n negative 2. So maksudnya, so this one, because we want to see the spline function are continuous function. Contohnya, maksudnya macam ni Contoh, let's say we have, katalah I kita, let's say 0. Okay. So that means our S1, okay, S1, ni lah saya guna, okay, SI plus 1, place balik have to be same as SI, XI plus 1. Maksudnya, S1 saya untuk X1 mesti sama dengan S0, X1. Contoh, apabila when I do these two functions, saya besarkan graf. Saya lukis balik graf tu. Wait I use another color. Let's say that's just now. This one kita just now we have two data point. Two data point macam ni Ini kan, dia macam ni kan. Sambung ni kan. Lepas tu ada lagi lah kan. Okay. Yang tadi, X0, X1. So, okay, satu lagi. Kejap. Satu lagi. Saya ambil yang tadi. Katalah this one. Ada lagi This is X2. So, ni, kat sini, this is the S0. And this one is S1. Apabila saya gantikan this equation dengan X1, dia mesti sama dengan equation yang, saya guna equation yang S1, tapi saya gantikan nilai yang ni. Dia mesti sama. Kalau sama, maksudnya dia barulah sambung. Ada penyambungan kat sini, at this point. Okay? So it have to be same. Maksudnya, if let's say this one, if I look at this one, you look at here, this one, S1, dia akan sambung yang ni. Dia sepatutnya sambung yang ni. So tak kira. So apabila saya ganti, when I substitute the value of X1 in this S0, X, this equation, you'll get the same answer when I substitute X1 in this equation. Okay? Boleh. And then continue. The fourth. Yang keempat This one fourth. Dia kata S prime I plus 1 X I plus 1 have to be equal S prime I X I plus 1 for each I equal to 0 until n minus 2. So this one you want to check, okay, whether the spline function are smooth or not. So if have to be equal in order the spline function are smooth and don't have any sharp corner. Or it means that the slope are continuous. Kalau contoh kepada just now, yang tadi ni, contoh yang ni, apabila saya beza, Okay, and you know, kalau beza kan biasanya divide dx. That mean a tangent line, a slope, right? Mesti let's say I have this equation and I do divide dx and first derivative. That mean saya dapatkan dia punya slope. Okay, so apabila saya dapatkan ini punya slope dengan ini punya slope, it have to be equal. Kalau tak equal, maksudnya sini at this curve dia akan tajam macam ni. Color lain apa, color apa lagi? Hijau, orange. So because I want this curve is smooth, I don't want it sharp like this. Yang ni tak boleh, tak nak. Kalau dia sama, that means it will have a curve like this, a smooth curve. Okay. Okay, and then the fifth criteria, okay, the second derivative of the spline function xi plus 1 have to be equal to the second derivative of si, okay, for xi plus 1. Maksudnya kita beza dua kali. Kan? Contoh yang ni, saya beza dua kali, si ni dia mesti sama dengan yang ni juga pada titik yang itu. Kan? Saya gantikan x1 kat sini, saya beza do the second derivative for this function for both. When I substitute the value of x1 here, dia mesti sama juga. So maksudnya, the meaning here is that the curvature functions are continuous. Dia sambung. Dia bukan setakat buat tangent line yang curve, yang tak sharp macam ni, tapi dia sambung. Kalau dia nak sambung antara satu function S0 dengan S1 have to be continuous. Okay, this is all 5 criteria. And then the last one is say that one of the following sets of boundary condition is satisfied. Kalau lah the second derivative for the first cubic spline sama dengan the last one and equal to 0, that means this one is natural boundary, natural cubic spline. Contoh macam ni. So maksudnya S0 kena sama dengan kat sini S6, S6 and have to be equal to 0. Kalau 0, that means this is the natural cubic spline. Okay? So far, any problems? Maybe we go for the example, how we're going to check this one, whether this one is a spline function or not. So far, okay. Semua kelas, okay. Sharil, okay or not, Sharil?
Yes, what?
Okay or not?
Okay.
Sambung. Selina, okay, Selina?
Okay, Doctor.
Selina, you have your lunch already. You come in earlier.
Yes.
Have an early lunch. Okay, so we continue with the example. If you want to see, look at your books in page 94, example 4.9. 4.9. Where's my water? Page 94. Show that the following function is a spline function. Okay, it's given that this spline function. Okay, saya boleh jadikan, kalau awak tengok saya boleh jadikan as x ni, saya jadikan this one is as not x. And this one is as was x. Okay, macam ni saya tulis balik I write it back. Saya tulis macam ni. Okay, first and foremost, go back to the tadi criteria. Alamak, sepatutnya saya paste ke ini ke sana senang sikit tengok criteria. So criteria paste ke sini. Wait. I go back the criteria just now. This one. Copy and paste here. Oh, you're very slow this one. I copy. 4.9. Didn't come out. How didn't come out leh. This one. Okay, this is the just now the condition. Okay. I'll go back to just now, the condition. First condition, it said that Sx is a cubic polynomial denoted by Si0 xix on the subinterval xi xy plus 1 for each I equal to 0, 1 until I minus 1. Okay, so kita terus pergi check kepada the first condition. Okay, we direct go to the first condition. Merah dulu lah. So kalau ikutnya kita punya XR Sx is actually equal to okay, we have Sx not x, and this is the x power of 3 plus 3x2 plus 1, and this one for x, okay, -1 until 0. Okay, and then we have the second one, this one S1x equal to minus x power of 3 plus 3x squared plus 1, and this one is x for the x 0 until 1. So kalau ikutnya betul lah, dah the first one dah, di mana yang ni dia mesti ada dia punya anak-anak with dia punya subinterval. And one more thing, dia punya subinterval yang ni dia kena continue dengan ini. Boleh faham tak? So that means here x0 is -1. Yang ni. x1 is 0. And then x2 is 1. Boleh tak? Okay. So maksudnya x1 ni dia kena continue. And dengan this one. Okay, so we go to the second condition. The second condition, it say that Sx have to be equal to Fx. Okay, for this example, the Fx is not given. The value of y. The value of y. Kat sini tak ada. Dia bagi x, dia tak ada bagi value of y. So we no need to prove lah since it's not given. So Fx is not given. Macam mana nak proof? Tak dapat proof lah. Okay, we go to the third condition. Third condition is saying that this one Si plus 1 xi plus 1 equal to Si xi plus 1. Maksudnya sepatutnya Si plus 1 maksudnya kita sekarang ada dua je kan? Xi. So, xi plus 1. Kalau lah sini, ini adalah I. Katalah I is 0. That means I plus 1, that means 1. So, this one lah, I value x1. That means x1 have to be equal with x0, x1. Maksudnya, apabila saya ambil equation, this equation, saya ganti dengan x1. That means 0. Kena sama dengan apabila saya gantikan x1 dalam this equation juga. So that means ambil dulu x1 punya equation. That means negative x power of 3 plus 3x squared plus 1 have to be equal with x. Yang ni power of 3, 3x squared plus 1. So x1 kat sini kan, x1 is 0 yang saya cakap tadi. So that means saya gantikan, I substitute the value of x1. Oops, sorry. 0, 0, 1 equal to 0, 0, 1. Okay, so okay lah. Okay, ini okay. Yang ni dah okay. So the third condition, the fourth condition, sorry. The fourth condition. So fourth condition just now, it says that S prime, I plus 1 have to be same with S prime. So maksudnya, S prime 1 gantikan X1 mesti sama dengan X prime not X1. Sekarang kita bezakan. Okay, we do the first derivative. Daripada this one, beza. Jadi macam mana? Masih ingat tak? Your maths before this. Apabila buat beza. So that's mean, daripada sini, so 3 bawa ke depan kan? So maksudnya, become, negative 3. Lepas tu, X square tu, dah tolak 1, become 2. Right. Plus with, okay, these 2 bring to fun. So 3 times 2 becomes 6. Yang X square tu dah minus 1, tinggal X sahaja. So that means 6X. Okay. And 1 tak ada X apa, tak ada apa. So we just tak ada lah. Okay. So here, sama juga, cuma tak ada tanda negatif. So here become 3X square plus 6X. So saya nak ganti masuk X1. So X1 just now is 0, right? Ganti masuk X1. So that means 0. Both are same. So sama. So apabila sama, that means at these conditions, the spline function are smooth. And then it don't have a sharp slope ataupun ni lah sharp corner. And then fifth conditions, the second derivative of Si plus 1 have to be same as second derivative of Si. So katanya S derivative mesti sama dengan S derivative. Okay, beza lagi daripada yang sini. This equation kena beza lagi sekali lagi. So here 3 bawa ke depan. So become negative 6. Negative 6X. So X square dah tinggal X sajalah. So plus 6X becomes 6. Okay. So here sama juga will be 6X plus 6. So ganti masuk nilai our X1 is 0. So it becomes 6 equal 6. So maksudnya yang ni okay, dia memenuhi, it satisfied the criteria. So that means these spline functions is the curve functions are continuous. So maksudnya sambung lah. Contoh when we draw we have point like this. Let's say this is a X0, this is a X1, this is a X2, and we have a graph like this. So maksudnya ini X0, X1. Lepas tu here, this is S0, this is S1. So that means it's continue, it's mula-mula, it's these functions, yang ni adalah the whole, this one is fx lah. So dia melalui semua titik, go through all the data point for the first conditions. Okay, and that's, sorry, this one. This one tak ada diberi. Tapi it can be sepatutnya betul lah. Sebab we have like all coming from the same. Apabila kita gantikan dia mesti sama. Okay, and then the third criteria yang ni has is continue. S0 akan continue dengan S1. This function. And the fourth criteria, dia punya this one is very smooth. It don't have a sharp corner. And the last is they have a curve that is continue. So cuma last kali sama ada we want to check or not whether this is a natural cubic spline or not. The last one is S prime X naught have to be same with S prime Xn. So X naught Xn kita 2. So tadi kan this equation. Let's take back this equation. Let's type back these equations. Negative 6x plus 6 equal to 6x plus 6. So x naught is negative 1. Ni. X naught is negative 1. Xn or x2 is 1. Negative 1 dengan 1. So masukkan. Kejap. This one should be 1 and this one should be not 1 and then this one negative 1. So that means 0, 0 have to be equal to 0. Betul lah. Okay, so this is the natural cubic spline. Sebab dia punya S double prime for x naught is equal to n, x naught sama dengan kosong. Okay. Okay or not?
Doktor, ulang yang step ke-6 tadi.
Huh?
Step
Step
6.
Oh, this one eh?
Yang last kali tu.
Yang last kali. Contoh yang ni kan, dia kata kalaulah boundary, okay, dia punya boundary kita nak tahu the first dia sepatutnya, maksudnya yang first kali apabila kita gantikan nilai first kali x0 lah kan, lepas tu ada x1. So tengok saya akan gantikan, for sure saya akan gantikan x0 dalam this function lah. Okay, lepas tu untuk x1 saya akan gantikan function yang last kali. So kalau sini, sebab saya ada sini saya ada 2 saja. So now it should be terbalik eh. Silap eh. Kejap x0 should be, let's say go back prime. This one is should be xn. Okay, sama dengan s prime not x0. Okay, have to be equal to 0. So kita punya s1 prime, sorry just now x1 double prime, ini satu ni betul, ini this one is negative 6x plus 6, yang ni yang ni saya salin balik, sama dengan saya ambil balik yang ni kan. Okay, so saya punya xn, x2 lah kan kat sini, sebab saya cuma ada data point saya x0, x1, x2 ni saja. So yang ni adalah x0. So go back to this one, x0 adalah negative 1. Okay, x0 negative, kat sini x0 kan, sini x0 saya gantikan negative 1. So saya punya x2 is 1. xn lah kiranya, xn last kali, nilai x yang last kali, data point yang last kali. So this one is 1 plus 6. So negative 6 plus 6 sama dengan negative 6 plus 6. So 0 equal to 0. So dia mesti sama 0. Kalau dia sama dengan 0, dua ni sama dan adalah sama dengan 0, that means this one is the natural cubic spline. Boleh? Tadi saya kira salah. Mana salah? Tak ada. Tapi masukkan terbalik juga. So this one we use this one. So boleh ke? Siapa tadi tanya tu? Syaril ke siapa?
Faham. Okay.
Boleh. Okay. So now we go to so this is the dia punya criteria. This is only the criteria for the spline polynomial. So now we want to find this, kan awak belajar cuma cubic kan, natural cubic spline. Maksudnya kita sekarang nak belajar macam mana kita nak dapatkan this equation S ni, yang kecil-kecil ni, semua ni, yang ni. Maksudnya this one lah. Macam mana kita nak dapatnya ni? This equation, semua ni. Okay? So now I go to the procedure. Okay, this is a procedure. How we are going to construct construct natural cubic spline. So here say that procedure of constructing natural cubic spline polynomial. So the first step, construct the divided difference table using the following formula. Okay. So kalau formula yang ni awak pun tak perlu ingat lah, semua ni kalau keluar test ke final formula akan is given. So we don't need to memorize, but you have to remember the step. It won't come out like step 1, step 2. No. Dia akan bagi continuously equation saja. Dia akan bagi macam ni. This one. Okay, and this one. Okay, dia akan bagi yang ni, yang tengah-tengah ni, semua ayat ni tak beri lah. Tak ada cakap. Tak ada cakap pun dalam ni. So it won't give you. So only give you the formula. So you have to know how to use the formula, how to apply it. So first and foremost, we have to find HK. Okay, sebelum ni kita guna like I. Start dengan I equal to 0, 1 and so on. Untuk yang ni, okay, sama juga sebelum ni kan. Contoh polinomial sebelum ni kita guna P and X kan. Macam ni. Sekarang kita guna S. Okay. Cuma kita tukar dia punya term ni saja, tulis ni. Contoh sebelum ni kita guna I. Untuk yang ni kita gunakan K. Boleh Kita akan guna K. And so on until N macam tu lah. Okay. So, the first step, we have to find HK. Okay. And then find DK. Saya rasa saya tak terang dululah dia punya formula. Nanti when we go to the example and then you know, cakap sekarang pun macam pening juga. And then we find BK. So, this is the 3 parameter that we have to find. H, D, and B. Okay. After that, after we get H, D, and B, so that we have to do the equation, derive the equation. So derive the equation based on this equation. Okay, based on this equation, and because this is a natural cubic spline, macam tadi, dia punya the first M first kali, the first M naught is equal to 0 and the last M also equal to 0. Maksudnya kat sini kita akan ulang lah, start from K equal to 0, ganti masukkan macam ni, H0, M0 plus 2, H0 plus H1, macam ni lah. Kalau MK plus 1, let's say K0, that means 1, plus H1, M2 equal to B0, macam tu lah kita akan ganti. Lepas tu seterusnya K equal to 1, K equal to 2, and so on. So depend on degree tu lah, berapa data point yang kita ada tu lah. Okay. After that, depending on how many data point and how many, okay, macam ni, apabila let's say, when you have 4 data point, katalah you have 4 data point kan. 4 data point. Okay. When you have 4 data points, that means your K will be equal to 3. Okay. Sama sebelum ni N. Kita guna N kan. K will equal to 3. So maksudnya sekarang, kalau nak cari this one, you will have like this. M0, M1, M2, M3 sampai 3. So yang M yang ni adalah kosong lah. So that means you have 2 unknown here. M1 and M2. So we have to find what is M1 and what is M2 in order to, and then after you get this, find M1 and M2, this one, find the unknown, M1, M2 until M minus 1. So let's see, N minus 1. Tengok N kita sekarang 3 kan, N minus 1 maksudnya 2 lah. Okay, so after that, when we know all the M here, nanti kita akan masuk dalam this formula pula. So this is the cubic spline formula to find the equation as X tu lah. So masukkan. So sama juga, we will start from K equal to 0, 1, 2, 3 until N minus 1. So kalau sini maksudnya K equal to 0, K equal to 1, K equal to 2, and K equal to 2 sajalah. Sebab K kita sampai 3. Okay? Boleh? Okay, kalau awak tengok dalam buku, your books they have alternative way to find. Dia kata alternative for step 4. Semua ada buku tapi saya tak tulis, saya tak ada kat sini. Saya tak letak kat sini. Why? I didn't teach students. This one is extra. Student to use this alternative way, because this alternative way normally we won't give you the formula, so you have to memorize the formula. So that's why I will prefer the student go to this way. Daripada kalau awak tengok dalam is page 95, dia tulis alternative for step 4. Maksudnya tak nak benda ni lah, panjang-panjang tak nak. So dia ada SI X equal to AI X minus XI power of 3 plus BI X minus XI square plus CI X minus XI plus DI, where I is from 0, 1, 2 until n minus 1. And A, B, C, kat sini kita sini ada A, B, C, D. This is the called as the Spline cubic polynomial coefficient. Di mana A, B, C, D ni pun ada dia formula sendiri. Here, A is mi plus 1 minus mi divided by 6hi. And B is mi divided by 2. C fxi plus 1 minus fxi divided by hi minus 2hi mi plus hi mi plus 1 divided by 6. Oops. And then D is the value of y actually, fxi. Okay. Tapi most of the time this equation is not given. All this equation is not given. So normally dalam test ke final, dia keluar yang ni saja, dia beri awak yang ni je. So depending lah, it will be faster, but you won't get, you have to memorize all the equations, all the formula. Sebab you have to memorize all the step. Bukan step saja, banyak topik lagi. So I won't recommend basically. Okay, so we go to the example 4.10. Okay, and then look through this one. Kejap to look 4.10. Try again. Something went wrong. Habis kali ni. What happened? Kejap I close this one. Sudah pening agaknya. Wait I started this one first. Wait how I'll just start a new one no, just right back It's very simple. Wait Well, give me some time Mungkin boleh take 5 dulu. Tu masalah dengan window. Okay already. I share the screen back. Semua okay? Are you still okay? Are you still with me?
Yes,
Ricky,
Doctor.
are you here? Still okay? Okay,
Okay.
kita sambung For example 4.10. Example 4.10 in page 96 in your book. Okay, it said that construct natural cubic spline if fx interpolates the data from f -1 equal to -1, f0 equal to 0, when x is 1, y is 1, when x is 2, fx is 0. So kita buat dululah. Ni okay, here that's mean. Yeah. Okay, this is alamak. That mean this is x0 lah. Okay. Yang ni adalah inilah nilai fx0 no. Saya dah x0. This is a x1, this is a x2, this is a x3 lah kan. And this is the f3, f2, f1. Okay. So we start with the just now procedure. Just now you said that step 1 we have to construct divided different table. Okay. Untuk tadi dia kata using the formula. Okay, saya tulis balik formula that's now. Just now we have to find three parameters, h, d, and k. B, sorry. So hk is equal to xk plus 1 minus xk. Okay, this one for k equal to 0, 1, 2, and until n minus 1. And then dk is fk plus 1 minus fk divided by hk. And this one sama juga. And then bk equal to 6 dk plus 1 minus dk for k equal to 0, 1 until n minus 2. Okay, so saya cari dulu these three parameter. Okay, so saya lukis sebelah sini lah. So we will have x. Sini k, sini x, sini f. Okay. Lepas tu we have h, d, and then b. So this is k. So k, this is k, this is fk, this is hk, this is dk, and this is bk. So kalau ikut data just now, we have 4 data point, right? K is 3, 0, 1, 2, 3. Okay. X0, this one, X0. Yang ni kan dalam ni. This is X0, -1. F0, yang ni F0 is -1. This one. This one, F0, okay? So, and then continue with X1. X1 is 0, F1 is yang ni. This one is 0, okay? And X2, this one is 1, F2 is 1, X3 is 2, and then F3 is 0. Boleh tak? Ke saya tulis sini? Saya besarkan, saya tulis this is X0, this is X1, this is X2, this is X3, this is F0, F1, F2, F3. Okay, so now I want to find H. So start from K equal to 0. So sekarang saya nak cari. Sekejap saya ambil saya punya nota. Nota entah ke mana. So kalau sini, I want to find the first one. Saya cari H naught. Okay, start dengan K equal to 0 lah. Saya start H naught. Kalau mau tengok this equation. Okay, so maksudnya X1 minus X naught. Betul tak? So X1 is this one lah. 0 minus negative 1. So become 1. So saya letak sini 1. So this is H naught. Okay, and then this one is H1. So saya continue H1. Based on this equation, X K plus 1. That means when K is equal to 0, this is K equal to 1. Okay. So H1 is equal to X2 minus X1. So X2 saya 1. X1 saya kosong minus. So become 1. So I put here 1. Boleh? Now K equal to 2. So H2 equal to X3 minus X2. That means X3 is 2 minus 1. So 1. So here is 1. Dah. So because kat sini kita buat sampai from K equal to 0 until N minus 1. N kita 3. So sampai 2 saja. K equal to 2 only lah. So here, dah. Boleh lah. So this is the value of H2. Semua okay? Semua okay ke?
Okay, laju.
Kata
Laju sangat? Boleh laju lagi? Ke apa?
boleh.
Terlalu can be more fast, is it? Okay, now we go and find this one. D. Oops, sorry. This one, dk. Okay, now we want to find dk. So based on equation here, sama juga, start from k equal to 0, we find d naught. D naught equal to f1 minus f naught divided by h naught. So f1 mana ni? 0 minus f naught is negative 1 divided by h naught is 1. So become 1. So here is 1. D naught. And this is D. This is D naught. Okay. And D1, K equal to 1. D1 equal to F2 minus F1 divided by H1. So that means F2 is 1 minus 0 divided by 1. So 1 as well. So this is 1 as well. And then K equal to 2, D2 equal to F3 minus F2 divided by H2. So F3 is 0 minus 1 divided by H2 is 1. Yang ni H2. So become negative 1. So this one is negative 1 and this is D2. Okay. So and then we dah selesai lah. And then go to B pula. Now we go and find B. This one based on these equations. Saya tulis sini B. So start from K equal to 0, B naught equal to 6, D1 minus D naught. So that means 6 times D1 is 1 minus D naught is 1 as well. So sama dengan kosong lah, 0. So that means here this is a 0. So this is B naught. Okay. And then K equal to 1, B1 equal to 6, D2 minus D1. So that means 6, 1 minus 1 macam ni. So that means negative 12. So this one is negative 12. This is B1. So katanya, kalau untuk B, we do until start from K equal to 0 until N minus 2. So K kita, N kita 3. 3 tolak 2, that's been 1 until B1 only. So dah, selesai. Itulah. So this is the whole value of the Newton divided difference punya table. So dah. So now step 1 dah selesai. So we go to step 2. We have to derive the equation. So step 2. Okay, we have to. Okay, for natural cubic spline, M0 is equal to 0 and then Mn is 0. So sekarang Mn kita berapa? 3 lah kan? So that means M3 is 0. Okay, so now we do the based on the formula given. Yang tadi yang panjang-panjang tu. So saya tulis semula dia punya formula. So dia punya formula HK MK plus 2 HK plus HK plus 1 MK plus 1 HK plus 1 MK plus 2 equal to BK based on this formula. So saya start from K equal to 0. Saya ganti masuk. So this become H0 M0 plus 2 H0 plus H1 M1 plus H1 M2 equal to B0. So saya akan gantikan. So remember this one M0 have to be equal to 0. So this one is 0. So totally ini tak ada ni lah, tak ada value lah. So we continue. H0 just now. H0 is 1. Ni. H0 is 1, H1 is 1. So saya ganti masuk. So now 2, 1 plus 1, M1 plus H0, H1 just now is 1, M2 equal to B0, 0 lah kan? B0, this one, 0. So that's become 4 M1 plus M2 equal to 0. So this is the first equation. Okay, and then we continue with K equal to 1. So H1 M1 plus 2 H1 plus H2 M2 plus H2 M3 equal to B1. So H1 is 1 M1 plus 2 H1 is 1 plus negative 1. Ini H1. Okay, that is D. Okay, 1 M2 plus this is 1 M3. Okay, go back to just now. This one M3 is 0. So that means this is 0 equal to B1. B1 negative. This one negative 12. So ini cancel out. So become M1 plus 4M2 equal to negative 12. And this is the second equation. So, dah lah. Sebab this one, say what yang ini kita cuma nak perlu buatkan sampai K minus K dia tu sama start from 0 until N minus 2. So N minus 2 dah 3 minus 2, that's mean 1. K sampai K equal to 1, that's okay. So sekarang we have two unknowns. Look at here, M1, M2, and we have two equations. So we have to solve this one. Solve this equation. So the step 3, solve unknown. M1, M2. So tak kisahlah what type of the method that you want to solve. You can use the system of linear equations that you learned before, or you can also just use calculator. Okay, so I go I try to use, okay, same if in the book they it used the Gauss elimination. So this one, we have two equation, right? We can put in the matrix form. 4, 1, 0. This one, 1, 4, negative 12. And then we solve it in Gauss elimination. So kalau sini, saya nak, let's say this one, saya nak hapuskan yang ni jadi kosong. So saya akan jadikan negatif. Yang ni 1/4. Let's say this one is R1, this is R2. So R1 plus R2. Okay, so let's check. Let's say I put here. So let's put the equation here. 1/4 alpha A plus alpha B. Now belajar sebelum ni. Calculate A. So R1, let's say this one. This is 4. B is 1. So is it get the 0? Okay. Okay, then okay. So dia akan jadi yang ni masih sama. Cuma this one will become 0. And then the next one, calculate. So A is 1. B is 4. Yes, siapa ada soalan ke? So that means 15/4. And then want to find this value. Yang sebelah sini pula, this one. So we can calculate again. So A is 0. B is negative 12. So get negative 12. Okay. So we can find the value of M2 from this backward substitution, right? So from here, 15/4 M2 is equal to negative 12. So M2 equal to negative 12 divided by negative 16/5. Okay. Once you get M2, you can find M1. So just now, from 4M1 plus M2 equal to 0. So ganti masuk, and 4M1 equal to 16/5. Then M1 equal to, bagi dengan 4. So become 48/15. 48/15. Is it 48/15? No. Saya tengok buku terus boleh. Else you just this one. Okay, this one time with negative 1 dulu. Okay, bagi dengan 4. Okay, okay, 4/5. So now we already get M1, M2. So that means because M0 is 0, M3 is 0. And then M1 is 4/5, and 2 is negative 16/5. So the next step, we can do the equation already. We can do the cubic spline already. Cubic spline polynomial. So, saya besarkan. Step 4. Step 4. We have to construct. Panggil apa? I use the term in the book. Find the cubic spline. Find the cubic spline. Fx. Okay. So equation given like this. I write down the equation. Fkx equal to mk sig hk at k plus 1 minus x power of 3 plus with mk/6 hk x minus xk power of 3 plus with fk hk over 6 times hk, and this one is xk plus 1 minus X, and then lagi panjang, plus Fk plus 1 divided by Hk minus Mk plus 1. Awak jangan nampak formula panjang-panjang terus takut It's nothing actually, you just substitute. Ganti masuk sahaja. And then this one is X minus Xk. Besarkan sikit lah dia punya size. Okay. So now, start from K equal to 0. And then we find the spline cubic. So K equal to 0. Start with K equal to 0. So this means S naught X equal to M naught over 6 H naught X minus X1. X1 minus X power of 3 plus M naught H naught X minus X naught power of 3 plus F naught over H naught minus M naught over 6. H times H naught X1 minus X plus F1 over H naught minus M1 over 6 times with H naught X minus X naught. Macam ni. So, just now remember our M naught is 0. Okay. Lepas tu tadi M1 kita 4 over 5. And then M2 is negative 16.4. So remember just now, kita punya H naught, H1, H2, semua pun satu. H naught, H1, H2, semua satu. Okay, so saya masukkan. So cuma F. Okay, so sekarang, since just now, this one, M naught is 0. So ini dah 0. So this one, S naught X so this one 0. X naught. Saya masukkan satu-satu lah, ganti satu-satu. Sekejap nanti pening awak. Sekejap saya ulang-ulang balik. Okay. So sama dengan, okay, M naught kosong. 6 darab 1. So this one X1. Oh, betul lah. X1 is negative 1. X naught is negative 1, X1 is 0. 0 minus X, power of 3, plus with M naught is 0 over 6 over 1. And then X minus X naught. X naught is negative 1. Negative 1, macam ni, power of 3, plus with F naught, F2 value of Y. Just now, this one F naught is negative 1.
Doctor, the M1 is 4 over 5. The M1.
Which one? I put already. M1, 4 over 5. I got substitute already. Haven't I? Oh, this one. This one is, oh, sorry, the equation I write wrongly. It should be, this one is K plus 1. This one is K plus 1. This one the second, okay. This one is K plus 1. This one should be 1. Okay, so this one is not 0 lah. So this one is, sorry, tengok saya silap. So this one is 4 over 5. So now, F naught just now is negative 1 over H naught is 1 minus 0 over 6. H naught is 1. And then X1. X1 is 0 minus X. Plus with F1. F1, kalau tengok table just now, F1 is 0. Betul? F1 is 0 0. Tengok table. Okay, 0. This one F1, 0. Kena refer. Okay, and then H naught is 1 minus 4 over 5. 4 over 5. Yeah. 4 over 5. This one 6. H naught is 1. X minus X naught. X naught is negative 1. So macam ni. So ini kosong lah. Okay. So this one 4 over 5 divided by 6. 4 over 5 times 1 over 6. 4 over 30. Okay, 4 over 30 become 2 over 50. 2 over 15. So sini sini. Sekarang kita sini sini. Okay. So here x plus this 1. Power of 3. And then plus this one 1 minus this one becomes 0. Lepas tu yang ni 1 is negative 1 times with negative x. So become x. Okay. Boleh tak? So ini kan negative 1 times with negative x become positive x. And then plus with, okay, this one dah tak ada. So this one negative 2 over 15. Sorry. This should be negative 2 over 15. Lepas tu x plus 1. Macam ni. Okay, this is a s naught x. Boleh. So this is x naught. So then when k equal to 1, s1x will be equal to m1 sig h1 x2 minus x power of 3 plus with m2 over sig h0 x minus x1 power of 3 plus with f1 over h1 minus m1 over 6 h1 x2 minus x plus with f2 over h1 minus m2 over 6 h1 x minus x1. So become like this. So equal to, so m1 is 4 over 5. 4 over 5 divided by 6 times 1 and x2 0 1 2 x2 is 1 minus x power of 3 plus with m2 is negative 16 over 5 divided by 6 over 6 times 1 x minus x1 0 1 0 power of 3 plus with f1. So f1 tadi 0, is it? F1 0. F1 are 0. Zero over 1 minus 4 over 5 over 6, 1. This one x2. So x2 is 1. 1 minus x plus with f2. F2 is 1. That's 1 over 1. M2 negative 16 over 5 over 6. H1 is 1. X minus x. Apa eh? This one what I write? X1. Not 1. X1 is 0. To become like this. So kembangkan, selesaikan. So this one is 1 over 15. 1 x power of 3. Oh, ini dapat berapa ni? This one. 16 over 5 times 1 over 6. 16 over 30. 16 over 30. 8 over 15. Negative 8 over 15. So yang depan ni dah tak ada. So tinggal is negative because here already gone. So ini negative 2 over 15, 1 minus x plus. So this one is 1 minus 8 over 15. Is it? 15 minus 8. 15 minus bukan. Berapa yang ni dapat? Can I just using this one 1 minus become positive already. Plus this just now is 8 over 8 over 15. Okay. Sorry. Go down. Should be 15 plus 8 lah, 23. Alamak. 23 over 15. So x minus 0. That means x only. So this is, boleh, can simplify. Some more no already, right? Correct already, right? So ini simplify lagi sekejap. This one. (15) 1 minus x power of 3 minus 8 over 15 x power of 3 minus 2 over 15 1 over x plus 23 over 15 x. Okay, all 15 already. Okay, so and then continue when k equal to 2. Kita kena buat sampai k equal to it have to be like until n minus 1. So n is 3. So that means we have to do from k equal to 0, 1, and 2. So k equal to 2, S2x equal to M2 6H2 x3 minus x power of 3 plus with M3 over 6H1 x minus x2 power of 3 F2 H2 minus M2 6 H2 x3 minus x plus F3 over alamak F3 over H2 minus M3 over 6 times H2 please come up this one x minus x2. So M2 is negative 16 negative 16 over 5 1 and then x3 tengok balik saya pun tak ingat lah. So x3 is 2. F3 is okay. 2 is 2. 2 minus x power of 3. M3 is 0. So 0 ni saya tak tulis lah because it's 0. And then plus because this one is 0. So F2 just now F2 yang 2 is 1 over 1 minus M2 is negative 16 over 5 over 6 H is 1. So x3 is 2 minus x plus with F3 just now say 0. Betul kan F3 0? Long balik tengok tadi lupa lah. 0. x3 is 2, F3 is 0. 0 over 1 minus M3 is 0 as well, 6, 1. and then this one is x minus 1. So yang ni pun dah kosong, kosong, kosong lah, the whole things. So become this one negative 8 over 15. 2 minus x power of 3 plus 1 minus this one 23 over 15 as well. So 2 over x. Okay, so dah selesai. So dah dapat. Semua masih okay. Are you still with me? So now already get all the. Sekarang kita dah dapat. Okay, so now we get this one as not S1x. So S1x, and then this one is S3, X2x. Okay. So sekarang saya akan tulis. So I will write the whole, this one, the cubic spline based on the equation that I get. So saya akan tulis here, make it bigger lah. So sebab itu S lagi tebal lagi Sx is equal to, so I have 3 equations here. The first one is 2 over 15 x plus 1 power of 3 plus x minus 2 over 15 x plus 1. Okay, so this one is for x from -1 until 0. Alamak. Kenapa lah? -1 until 0. And then the second one is, kalau depan awak nak tulis macam ni pun boleh juga. That doesn't matter. It's okay. So let's say in front you want to put S x, x not x equal to, can also. So tak nak pun tak apa. So the second S1 just now is 2 over 15, 1 minus x power of 3 minus 8 over 15, x power of 3 minus 2 over 15, 1 minus x plus 23 over 15x. So this one for x daripada 0 until 1. So sini saya letak ke belakang. Sama. So this one is for x -1 until 0. And then the third one, this one, negative 2 over x power of 3 minus 23 over 15, 2 minus x. So this one for x from 1 until 2. So okay or not? Dah, ini lah. This is your natural cubic spline. Yang ni, Sx. Di mana Xx ini will have based on how many data points. So because this one we have 4 data points, so that means kalau lah tadi yang contoh tadi kan, when we have a graph like this, so for sure we have how many segments? So we have to have 3 segments. So one is S0, this one is S1, this is S2. So here we have 3 equations, 3 spline equations, and this is the whole natural cubic spline equations. So far, okay. Boleh exercise saja. Example. Dah tak ada masa dah. Cuma boleh example saja, tak boleh exercise lah. Class, are you still with me? Husnina, sorry. Husnina, are you okay? Are you still with me? Are you okay? Sampai sini okay tak? So far, do you have any questions? Let I stop recording. Oh, it's not here. Wait. Stop recording here.